So by this time, we should have a lot of stuff filled in. We've created the perpendicular bisectors. We've created the angle bisectors. And we've created the medians. The next thing we're going to create are the altitudes. Now, let's remind ourselves what an altitude is. An altitude is a line, segment, or ray that connects a side of your triangle to its opposing vertex. There was one more requirement. This line, segment, or ray also has to be perpendicular to this side. It'll make more sense once we fill one in. An easy way to find an altitude is to line up one of the inch marks with the side of your triangle. I know it's kind of dim, but you can see how I've lined up my 1 inch mark and this side of the triangle. We need to go until this side lines up with this vertex. When we have that, we will have found an altitude. If you'll remember, the altitudes don't have to meet inside the triangle. And since this is obtuse, it's more than likely going to result in a segment that's outside of our triangle. You can see it again when I start at the bottom and try to find a point or find the segment that hits this point. When I go along, you can see that I'm going to run out of room way before this edge even gets close to this vertex. So how do we fix this on the board? Well, we want to extend this side a little. We don't want to confuse ourselves. So line up your ruler with this side, and we're going to make a small dotted line that extends out the length of this side. And what this will do is allow us to keep our ruler aligned and also find a segment that's perpendicular to this line. Let's try it again. If you line up an inch mark with your side, as mine is down here, slide your ruler, keeping those two lined up until this edge hits this vertex. When that happens, we're going to draw in that segment, and that will be one of our altitudes. So it's still lined up, and I'm still sliding, and it looks like I've found an altitude. So what I need to do at this point is connect this vertex to the dotted line we just created. Remember, these are also perpendicular, so I just want to go ahead and create that little perpendicular mark. Take a moment, if you haven't already, and find that altitude. Okay, now that you've found that altitude, let's go ahead and find the altitude that connects this side to this vertex. We're going to do this the same way. Take a centimeter marker or an inch marker and line it up with this side. You can see that I've lined up the mark that makes my 22 centimeters with this side. And I'm going to slide my ruler so that those stay lined up until this edge connects to this vertex. So I'm just going to slide that up, keeping it in line until this edge meets up with the vertex. Now, what do you notice is about to happen? Just like over here, we ran out of room long before we could create a line that was perpendicular to this side of our triangle. So to make up for that missing room, we are going to have to extend this side with a dotted line. Line up your ruler and just make a quick dotted line that will extend this side. Should look similar to this, coming straight out from this side of your triangle. So we're going to start over. Line up a centimeter or inch mark with this side of your triangle. Slide your ruler until this edge touches this vertex. So we're sliding, 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 still sliding until our ruler meets up with that vertex. When the two line up, create a segment that goes from this vertex to our extended side and put in a perpendicular mark. Can anybody guess where our third altitude is going to be? Well, if you think about what an altitude is, a segment, line, or ray that's perpendicular to this side and touches our vertex. Do we have a segment on here that already fits that category? Sure we do. It's also this segment. Now, how did I know that? Somebody tell me. The way we know is because it's already perpendicular and it goes from this side to this vertex. So we've now filled in all of our altitudes.